Hello students. So today a new chapter, second order derivative. Previously in last few videos of the derivative we have just learned about the first order derivative. Now the first thing here, what is the term order stands for? Now order means, suppose a function is there y equals to f of x. This is a function given to you, and you have find that first of all dy by dx. Dy by dx means differentiating y with respect to x. So this is called first order derivative. First order, why first order? Because only once you have differentiate this. If you further differentiate this thing, that is twice differentiating, then that particular will be called as second order. And how we'll write this? See very carefully. This is dy by dx, first time differentiate, that's why it is called first order. Order means number of times a function is differentiated. Okay. Order means the number of times a function is differentiated. If it's differentiated twice, it will call as second order. That means we are differentiating y two times. That's why second order. If it is differentiated three times, then it will call as third order derivative. Now how we'll indicate or how we'll write second order derivative? See, first order derivative, that means dy by dx. Second order derivative we will write in this form. d2y by dx2. How will write? We pronounce it as d2y by dx2. We will say in this way, d2y by dx2. Okay, so this is a second order derivative. That is what I am saying, d2y by dx2. That is d dx of dy by dx. This is your first order differentiation. This is your first order differentiation. If you further differentiate this with respect to x, we will get our second order derivative. This is the first order. First of all, this is the function given to you, y equals to f of x. You have differentiated, that means you have find here dy by dx. Clear? Then you further differentiate this thing. That means further differentiate means again doing d dx of dy by dx. Now after d dx of dy by dx, the form you will get, that is d2y by dx2. So always you will say in this way, d2y by dx2, like this. So simply second order derivative means differentiating a function y two times. Okay. So now let's start with some simple questions of this topic. Now what is the question here? The question is, if y equals to log x by x, then find d2y by dx2. That means we have to find second order derivative. So first of all, we will find our dy by dx. So let us differentiate this thing. So you will write here y equals to log x by x. Differentiating both sides with respect to x. So we get for this side dy by dx and this side d dx of log x by x. Now this is in the form of division. So here we will use rule of division. That is, first of all, denominator whole square, starting with the, always start with the denominator. Okay, d dx of numerator minus, now interchange them, a numerator will remain outside the derivative, and d dx of x. So that is x, d dx of log x is 1 by x, we know that, log x d dx of x is 1 divided by x square. So here x and x will going to be cancelled. So finally what we get, 1 minus log x into 1 log x by x square. So this is our dy by dx. So we got our dy by dx. But what we have to find? We have to find d2y by dx2. So what we'll do? We will again differentiate this thing. So then you have to write in this way. Again differentiating, name this expression as 2, main equation as 1. Again differentiating 2 with respect to x. So that means if you differentiate dy by dx again, you will get here second order derivative, that is d2y by dx2. If you differentiate dy by dx again, that means second order d2y by dx2. And what is in this side? 1 minus log x by x square. That is d dx of 1 minus log x by x square. Now again division form, that is rule of division we will use here. X square, this is denominator part, and that's whole square. Now starting with the denominator, x square d dx of numerator minus, oops, no space, no, 1 minute. So again differentiating 2 with respect to x, we will get d2y by dx2, because dy by dx derivative again, that is d2y by dx2, and this side d dx of 1 minus log x by x square. That is, what is the denominator here? X square. Now x square whole square. Starting with the denominator part, d dx of 1 minus log x minus, now just interchanging them, d dx of x square. Now differentiating them, the x square whole square, that is x to the power 4, power to the power, that means power are multiplied, 2 into 2 4. Now here x square d dx of 1 is a constant derivative is 0, minus d dx of log x is 1 by x, minus 1 minus log x, d dx of x square is 2x. So after that, here x to the power 4. Now here plus minus minus. Okay, first of all 0 minus 1 by x is minus 1 by x. So x square into minus 1 by x, minus here 2x 1 minus log x. So for saving one step, what we can say here, what is x? Here x square. So if we cancel, what remain finally? Minus x minus 2x 1 minus log x by x to the power 4. This is your d2y by dx2. Here you can further simplify. See, in both the term x is common, you can take x common, that will cancel with x to the power 4. Okay, then you can open the bracket. I can directly write the simplified form. You can reach up to this. It will come x is cube, and here minus 3 plus 2 log x. This will be a simplified form. Just by taking x common from both the terms, x will cancel, this will become x cube, and minus 1 minus 2 minus 3 minus 1 plus 2. So this is a simplified form. You can if you simplify this factor, you will get this thing. Try this one. Okay, so this is all about the question number 1. So d2y by dx2, that is second order derivative, means differentiating twice. Clear? So now I have some home tasks for you. Okay, so there are total 4 questions. Question number 2, if y equals to x by root over x square plus 1, then find, oh, this piece. d2y by dx2. If question number 3, if x square plus y square equals to a square, then show that d2y by dx2 equals to minus a square by y cube, that is cube. Question number 4, for x square by a square plus y square by b square equals to 1, find d2y by dx2. And question number 5, if y equals to 1 plus x by 1 minus x, find d2y by dx2. So these 4 questions are homework for you. Just simply find that first of all their dy by dx, then further differentiate, you will get your d2y by dx2. Okay, so now the next question. Okay, question number 6 is an interesting question. You can see that if y equals to a e to the power 2x plus b x e to the power 2x, where a and b are constant, then show that d2y by dx2 minus 4dy by dx plus 4y equals to 0. So we have to prove this expression. So first of all, what we'll do, we will first of all find our dy by dx, then we will find our d2y by dx2, then we'll put in this left hand side, and we'll see that all the terms are cancelling out and the result will be 0. So let's start. So first of all, what is here? Given y equals to a e to the power 2x plus bx into e to the power 2x. Name this expression as 1. Now differentiating both sides with respect to x. So we will get here dy by dx. A is a constant. For the first of all, first this part, ddx of a e to the power 2x plus ddx of bx e to the power 2x. Now a is a constant. Constant will come out of the derivative. Now e to the power 2x. What is a e to the power 2x derivative? E to the power 2x into 2. You will remember the formula, ddx of e to the power mx is equals to m e to the power mx. This was the formula. Here m is 2. So thus using that formula, here b is a constant, taking out b out of the derivative, but here two functions are there. One is x, another one is e to the power 2x. So that means product rule. Product rule means, first of all, at a time only one function differentiate, other function will remain out of the derivative. E to the power 2x ddx of x. Now simply multiplying 2a e to the power 2x plus b, here x e to the power 2x derivative is 2 e to the power 2x plus e to the power 2x. ddx of x is 1, so no need to write that. So this is our dy by dx. Okay. So now we again differentiate this, or we can simplify one more step. Just opening the bracket here. Now this is our dy by dx. Now what we have to find next? We have to find d2y by dx2. So what we'll do? We will further differentiate this. Name this expression as 2. So again differentiating 2 with respect to x. So we will, in this side here, dy by dx. So here we will get d2y by dx2. Now see the first term, 2a e to the power 2x. 2 is a constant, we will keep 2a out of the derivative, and ddx of e to the power 2x plus next term 2bx e to the power 2x. 2b is a constant, 2b out of the derivative, only ddx of x e to the power 2x plus Last term b e to the power 2x. B is a constant out of the derivative. Okay. Now 2a e to the power 2x derivative, 2 e to the power 2x, 2b. Now again product rule. You will do that. I am just writing the result directly. Okay. You will solve this. It will be e to the power 2x plus 2x e to the power 2x. And here b, you have to solve this. I am just writing it directly. Here b into 2 e to the power 2x. So after simplifying we get 4a e to the power 2x plus, let us open the bracket, 2b e to the power 2x plus 2 into 2 4 bx e to the power 2x plus 2b e to the power 2x. Or we can see that here this term same, so we can add them. So if we add this, what we get? 2 plus 2 4. So I'm just directly writing this as 4. Okay. Now we will just put this all values in where? In the left hand side in this expression. Okay, so this is our left hand side. d2y by dx2 minus 4 dy by dx plus 4y. So first of all, d2y by dx2. What is our d2y by dx2 value? This is the value. Put it. That is 4a e to the power 2x plus 4b e to the power 2x plus 4bx e to the power 2x. We have put the same value. You can see that. Next, minus 4 dy by dx. Minus 4, now dy by dx. What is the dy by dx value? 2a e to the power 2x, then plus 2bx e to the power 2x plus b e to the power 2x. You can see that 2a e to the power 2x plus 2bx e to the power 2x plus b e to the power 2x minus 4. And the last one plus 4 into y. Y, that is the quotient part. What was the quotient in the y? Y was a e to the power 2x plus bx e to the power 2x. Now we simply multiply and then see. Okay, now let us multiply is 4a e to the power 2x, 4b e to the power 2x, 4bx e to the power 2x. Now here minus 4 into 2, 4 into 2, 8a e to the power 2x minus 4 into 2, 8bx e to the power 2x minus 4 into this part, that is minus 4b e to the power 2x. Now here plus 4a e to the power 2x plus 4bx e to the power 2x. Okay, now see 4a e to the power 2x plus 4a e to the power 2x, that is 8. 4 plus 4, 8, and here minus 8. So this term cancel. Okay, now next 4b positive, and again 4b, where is 4b? Oh, minus 4b, that directly cancelling out, so that is cancel. And here 4bx, that is 8bx, and here minus 8bx, so that is also cancel. So all the term are cancel out, so finally the answer is 0, which is equals to right hand side. Hence proved. Clear? So this type of questions comes in an exam where a function is given to you and you have to prove that this type of equations. Okay, so now let's proceed to the question number 7. Now there are more 3 questions. Question number 7, if y equals to root over 3x plus 2, then show that this. Simply again you will find here dy by dx, then d2y by dx2, then we'll put in the left hand side, adding, subtracting, you will get your answer 0. Try this one. Question number 8, if y equals to x cube into log of 1 by x, then show that this. And similarly question number 9, comes multiple times in the last few years. So this is one of the interesting question. If y equals to a e to the power mx plus b e to the power minus mx, then show that d dy by dx2 minus m square y equals to 0. So these 3 questions are also homework for you. So total till now 7 questions. Okay, now a new type of question. Okay, now question number 10. If y equals to log x plus root over 1 plus x square, then show that 1 plus x square y2 plus x y1 equals to 0. Now what is here y2 and y1? Simply remember that y1 means dy by dx and y2 means d2y by dx2. First term derivative y1, second term derivative y2. Okay, so that means y1 is here dy by dx, y2 is here d2y by dx2. So we have to require two things here, dy by dx and d2y by dx2. So first of all find dy by dx. So here y equals to log x plus root over 1 plus x square equals, this name this equation as 1. Differentiating 1 with respect to x, we get dy by dx, and this side d dx of, this question we have done earlier in the chapter of derivative. Some of the results I will directly use here. First of all, log. Remember that whenever the log derivative, whatever the term will be here, that directly come as 1 by x plus root over 1 plus x square. Okay. Now if you simplify in a simple way, if you say that this term, if we assume this term as u, this full expression as u, so that will, this is log u, log u derivative is 1 by u, then d dx of u. What was the u here? This is the u. I mean to say, suppose if you assume this expression as your u, so this is nothing but your d dx of log u, and d dx of log u is 1 by u by chain rule du by dx. And what was the u here? Just putting that value. Okay, so I've directly use that result. Clear? Now we'll differentiate this part. Okay, now further differentiating this, that is d dx of x, and here d dx of square root of 1 plus x square. X plus root over 1 plus x square. This side d dx of x is 1. Okay, now d dx of root over part. If you suppose 1 plus x square, I'm just doing the rough, I will directly write the result here. What was the term, what was there? D dx of 1 plus root over x square. This was the term. If I suppose 1 plus x square as u, then it will convert in the form d dx of root over u. Clear? Now what is d dx of root over u? 1 by 2 root u du by dx. d dx of root over u is 1 by 2 root over u into du by dx. And what was the u here? 1 plus x square. So directly putting here, what we get? 1 by 2 root over 1 plus x square d dx of 1 plus x square. Just using that result, root over result. What is the u here? 1 plus x square. Just putting here in place of u, just put 1 plus x square, you will get this. I'm just using the, Since we have done this question previously in the chapter of derivative, that's why I'm doing here the step jumps. Okay, now 1 plus 1 by 2 into root over 1 plus x square. ddx of 1 is 0, ddx of x square is 2x. 0 plus 2x, 2x. So after that, 0 plus 2x is 2x. We will write 1 by x plus root over 1 plus x square. 1 plus 0 plus 2x by 2 into root over 1 plus x square. Now here we can cancel 2. We can simply cancel here 2. So after cancelling 2 we will get here just x by root over 1 plus x square. Not taking the LCM, this is we are finding dy by dx. Taking the LCM, 1 plus x square plus x. Okay, that is, we can see that this term are same, so we can cancel these two terms. So finally what remain? 1 from the numerator part, only 1, and the denominator part only root of 1 plus root over x square. Okay, now this side dy by dx means you can write y1. Okay, now just do the cross multiplication. That is 1 plus root over x square y1 equals to 1. Squaring both sides, if we square both sides, that is 1 plus root over x square into y1 whole square equals to 1 square. What will get? Square root over square, that means it will simply 1 plus x square, and y1 square, that is y1 square, and this side 1 square is 1. Clear? See here is y1. From this step also you can simply find again differentiating d2y by dx2. That is another way. I am solving this question in another way. Whatever the way you like, you can go with that way. From here you can simply find again differentiating this expression. You can find here d2y by dx2, then put in these expressions, you will get your result, or by this method also, squaring both sides. Now we'll differentiate this expression. Differentiating both sides with respect to x, that is ddx of 1 plus x square y1 square, and this side ddx of 1. Now here two functions, that means product rule, 1 plus x square ddx of y1 square plus y1 square ddx of 1 plus x square, ddx of 1, a constant, that is 0. Now after that, 1 plus x square. Now very careful about this expression. What was there? ddx of y1 square. ddx of y1 square. What is the differentiation of x square? 2x. So y1 square 2 y1, but this is y1, this is x. These two are not same, so further differentiating. Okay, Now what is your basically y1? Y1 we know that y1 is nothing but our dy by dx. And again differentiating this, that means again if we differentiate y1, that means again differentiating this side also, ddx or dy by dx, that is this is nothing but d2y by dx2, or we can write y2. So dy by dx is your y2, 2y1 y2. So ddx of y1 square is 2y1 into y2. So we'll write here 2y1 y2 plus this side y1 square into this ddx of 1 plus x square, that is y1 square ddx of 1 is 0, ddx of x square is 2x equals to 0, that is 2y1 y2 1 plus x square, and here 2x y1 square equals to 0. So what is common between these two terms? We can say 2 is a common in both the term, y1 is also common, so only what remained y2 1 plus x square. From here x we have taken y1 common, here is y1 square, so what will remain y1 equals to 0. Now 2 product equals to 0, that means if we take this term to that side it will vanish, if we take this term to that side that will be vanish. So finally what will get y2 into 1 plus x square plus x y1 equals to 0. This is your proved. Okay, now many of you will find some difficulties of this step, so for that I'm doing the alternative way also. Okay, if you have any problem for this understanding, for getting some trick here, so I'm doing the alternative way for you also. So what was the y1 we get previously for this part? This was our equation number 1, right? Okay, y1 means nothing but your dy by dx. So let us again differentiate this thing. This was the equation 1. Okay, so that is d2y by dx2 we will get, and this side ddx of 1 by root over 1 plus x square. Or if we simplify this part, what we can write, I'm writing it directly, 1 plus x square to the power minus half. Can we write? Because what is the power? Root over means half, and we know that if any term from denominator goes to numerator, the power becomes negative. Clear? Now let us assume here, let u equals to 1 plus x square. So that is ddx of u to the power minus half. Now if you differentiate this, we will get minus half u to the power minus half minus 1 du by dx. That is, let us put the value of u. After that, minus half u to the power minus half minus 1, that is minus 3 by 2. ddx of u means 1 plus x square, and u is your 1 plus x square to the power minus 3 by 2, and 1 plus x square derivative is 2x. We know that directly. This is into. Now here 2 cancel, 2 and 2 cancel, minus x into 1 plus x square to the power minus 3 by 2. This is your nothing but d2y by dx2. This is your d2y by dx2. This is your dy by dx. Let us put these values in your LHS part. This is an alternative way of solving this question. Okay, so this is your LHS. So let us put the value 1 plus x square into y2. What was the y2 you got? This is the y2. Minus x 1 plus x square to the power minus 3 by 2. Clear? Plus x into y1. Okay, x. What was the y1 we get? This is the y1. That is 1 by root over 1 plus x square. Okay. So now minus sign x. Now here what we can say that this is in the form of multiplication. And 1 plus x square and 1 plus x square. Their bases are same and they are in the form of multiplication. So their powers are added. So what is the power here? 1. So 1 minus 3 by 2. Okay, x. Now we know that if we take this term, what is the power of this term? First of all, here root over means we can write it as 1 plus x square to the power half. And if we take any term from denominator to numerator, it becomes minus half. Okay. 1 minus 3 by 2 is minus half. Minus half. Same terms, this is plus, this is minus, so both will cancel. Answer is 0. That is your RHS. So I have done 2 methods for the same question. Which method you like, you can go with that method. Okay. If you like this one, you can go with that. You will get the full marks. If you like the previous one, you can also use that method also. Okay. So now the next question. Oh no, next question. That will be a bonus question. Okay, so this is all about for second order derivative. There are some homeworks. Total 7 questions is homework, and 1 question will be a bonus question. Try that bonus question. This is all similar to the question number 10. So this is a bonus question. If y equals to x plus root over 1 plus x squared to the power m, then show that this. You will try this question. Only one hint can I give to you for this question. Take log both side. If you take log both side, you will get here log y equals to this m will power come in front. That is m log x plus root over 1 plus x square. Then follow question number 10. It will be easy for you. And this is the result of the previous bonus question. Some of the consistent names are coming. And one more thing, the homework and the bonus question for the logarithm differentiation part 3. All the solutions you will find in the description of that particular video. So if you want a solution, just go to that video description part. You will get your solution of homework as well as the bonus part. So this is all about for today. In the next class, we will come with a new topic. Till then, thank you for watching all the video.